Okay. So here the classification of chiral drugs. So here the drugs are classified into various types based on their pharmacological activity and their what is that the therapeutic activities and the side effects. Right. So here you see first the NSAID. Right. Here the NSAID means non-steroidal anti-inflammatory drugs. Here. So these are the analgesics means where the painkiller. Okay. The side comp. Uh, like these NSAID, it is non-steroidal anti-inflammatory drugs. Inflammation means you see, you know that, right? With the painkillers here. And okay, so here the steroids, generally we know that these are the painkillers, but and here you see the steroid compound, they also act using as the painkillers, but you can see some undesirable side effects here. Okay? Undesirable side effects. That's why generally we prefer the NSAID drugs here. But these steroidal drugs are okay. The steroidal drugs are not preferable, but few of the right the few of the uh, get released by the but you will have some unwanted properties like unwanted side effects here. Okay, that's why it is better to don't go with that steroidal drugs, and the recommended is NSAIDs here. Right. Next here the beta blockers. Stage two drugs here. Uh, is system so where the and one okay alpha one alpha two and beta one beta two and okay gamma here. So these are five subunits here. The histamine receptor there are five subunits are there. Okay, so here the drugs are which are blocking the beta receptor. And we have so many examples like what is that propranolol, atenolol, okay, captopril. Okay? So those are the antihypertensive drugs. Yeah? And next one is the ACE inhibitor. Right? Here the beta blocker. Beta blocker means here the receptor, where the receptor, it is blocking the receptor active site here. And here the ACE inhibitors. ACE means angiotensin converting enzyme, isn't it? The ACE is the angiotensin. Okay, angiotensin converting enzyme. Which contains Right? So here the angiotensin. Angiotensin is a generally it is a what is that polypeptide where it is taken the two types here. Right? Here the angiotensin 1, angiotensin 2 here. Where the angiotensin 1 is the okay, it is decapeptide and it is a octapeptide. Isn't it? It is a decapeptide, it is octapeptide. So generally here angiotensin 1 converts into angiotensin 2. Decapeptide converts into decapeptide converts into octapeptide in the presence of ACE. Okay, so ACE in presence of ACE, it is converting into octapeptide, and this is inactive here generally, and it is your active form, right? It is active form. This is inactive form here. So inactive converts into active form, and here this angiotensin 2, it regulates your BP, blood pressure, right? It regulates the blood pressure in the in the heart, like blood stream here. It regulates your blood pressure, BP. So when this ACE gets overactivated, then the more conversion of angiotensin 2 will be takes place. Then means more conversion in the sense where the when it is more activated here, the more formation of angiotensin 2. Then it will be right. So it increases the blood pressure. Generally, it leads to development of the high BP, high blood pressure. Okay. So in that case, we'll use we'll block this ACE, angiotensin converting enzyme, with some drug molecules like captopril here, right? So this captopril will be bind with the ACE and it make that ACE inactive. Then that particular high blood pressure will be converted into normal, right? So here is the drugs, NSAID drugs and ACE inhibitors, okay, beta blockers are given here. You see, right here the non-steroidal anti-inflammatory drugs. Here the examples are like alpha-aryl propionic acid here and ibuprofen, okay, naproxen here, naproxen, oxaprozin. So all these are the NSAID drugs here, and the beta blockers. Here is a examples under this beta blocker like propranolol, atenolol, okay, and acebutolol. Right? And the AC inhibitors example is a captopril and lisinopril here. Captopril, lisinopril, ramipril here. All these are the beta blockers. Right? Next, the important is 5 hours rule. Right? 5 hours rule, very important here. Okay, 5 hours rule. It is somewhat important topic. So, what is 5 hours rule here? So, generally here the 5 hour rule suggests us to decide the dosage here. Okay. So here the when a more active pure enantiomer is used, the higher the eudesmic ratio. So what is eudesmic ratio here? It is a ratio between etomer and distomer here, isn't it? It is a ratio, eudesmic ratio. Okay. Eudesmic ratio equal to the ratio between the etomer by distomer. Etomer by distomer here. So what is etomer here? The more active isomer of the compound is the etomer, and distomer is the less active compound of the that okay, the less active isomer of the compound is a distomer here, and the ratio between these two is a eudesmic ratio. Okay, so generally here the pure enantiomer is used, means when a more active pure enantiomer is used. So the generally it is having a higher eudesmic ratio. Pure enantiomer means
only the one compound here, the active compound, not racemate, right? If you use a racemate, then obviously that eudesmic ratio value will be low. But here, where when you are using the pure enantiomer compound, right? So its eudesmic ratio is low. Eudesmic ratio is high. So when the eudesmic ratio is high, so it suggests to use a low dosage here because it is in pure form, right? So you can use a low dosage here. This is called the Piper rule. Piper rule, right? Suggests us to how much dosage is used based on the purity of the enantiomer here. So if your eudesmic ratio value is high here, so when you get the high eudesmic ratio value, if you take the eutomer in isolated form or the eutomer in the pure form here, we are not using any distomer along with the eutomer. No combination therapy, no combination treatment here. In that case, obviously the eudesmic ratio value will be more. So if the eudesmic ratio value is more, then it is you can use low doses of the particular drug here, right? And generally that dosage this means the dosage prescription that the dosage what is that the evaluation, right? Here the dosage evaluation, it will be depending on its biological activity here, right? Biological activity, that is called the medium effective dosage, ED50, right? ED50 here. Here you see the, yeah. So on this particular x-axis where we are taking the dosage level, right? The dosage level is taken by milligram by kg of body weight here, right? So generally we'll consider the body weight also, right? Here, what are the things you will keep in your mind when you are deciding the dosage? So all the factors, right? All the factors you should keep in your mind while you are deciding the or while you are prescribing your dosage here. Okay. So the fixing the dosage. Okay, fine. So here milligram per case means how much right, the compound, active compound, other drug compound is taken for the weight. What is the weight? It may be the what is that? Right, 10 kgs or 20 kgs or 50 kgs, 60 kgs, whatever, right? So that will be taken here. And if it is a preclinical trial here, right? So in the preclinical trial, generally we'll uh, apply, right? So we'll apply on that uh, what is that, mice here, rat, okay, mice, rat, and guinea pigs here, guinea pigs. They are the experimental animals. Okay, so we'll apply on that particular animals. So generally it is a preclinical trials. Right? Preclinical trials. So in the preclinical trials, generally we apply that particular medicine or the invented drug compound on the animals here. Right. So while you are doing this experiment on the animals, so generally we'll take the means we'll divide the groups here. Okay, so we'll divide the groups like 50 what is that, 500 mg or 1 gram, means 10 grams, 20 grams, 15 grams, so like that in the gram wise, because the guinea pigs and mice, these are very low weight, like 1 kg, 2 kg, up to 1 2 kgs here, not much weight here. Okay. So here we'll keep some factors, right? Like the weight of the body and the age and what is the gender of the uh, uh, right, the experimental trial here. So all the factors will keep in our mind. So when you are going to decide the dosage here. Okay, and we'll see the percentage of individual responding here, right? So out of, for example, we are taking the 100, right? So one to get the 100, the experimental trials are taken, right? So here is a 50. So generally we'll consider 50, right? If the 50, uh, right, the 50 individuals or the experimental trials are responding to this, then we'll pass this particular medicine here, right? So no need to the check up to 100 here. Anyhow, we'll go by the 100, but if we need only the if the 50% is responding to this, okay, yeah. So based on that, we'll decide the the dosage here. And while we are deciding the dosages, so generally we'll consider, right? So we'll consider all the factors like weight, okay, genetic properties of the individual here, right? Body weight here, genetic properties. Genetic properties means if any genetical diseases are there, okay, like what is that? Genetical diseases like dwarfism and diabetes, all these things. If they are affected with that, then uh, we'll take into the consideration that what is that properties here and the food habits here. So food habits generally, place to place, the food habits are different. Like if, in our south region, generally we prefer the rice here, and in the north region, generally they will prefer the some rotis and some other. Right? They will consume rice very less, but here we consume rice more. So like that, the food habits. Okay, and some the age factor also, right? So age factor, so that also we need to keep in our mind here, and we'll based on that factors here we'll decide the dosage here. Okay, so this is the basic about the chiral drug. Then we'll see the synthesis of chiral drugs here. So the synthesis of chiral drugs. So in this synthesis of chiral drugs, generally they will ask the right, the synthesis of some drugs here. So you have to remember, you have to practice synthesis mechanisms and the reactions for this particular. So here in this particular topic, you can go with means for all the drugs reactions and the mechanisms here. So you can select selectively you go. Okay, so you choose 3 or 4 drugs and you flow with that. Okay, so because it is the reactions are very lengthy and difficult to remember here. This is the synthesis of ibuprofen. Right, so ibuprofen, it is anti-inflammatory drug. Okay, and generally in the normal right? So in the market, uh, the name ibuprofen, the blue is the paid drug. And generally it has many means so many problems like right, so what is that, fever and NLC and some other inflammatory problems here, right? So so many problems can be cured by this your brufen or the ibuprofen here, right? And in the Yes, is active and R is inactive here, right? R is inactive means it don't have any biological importance or pharmacological importance. Only the X isomer is the active one. And here is this is your the structure of the protein here, right? Here the what is that? So the acid group is there, and here the isopropyl ring is there. Methyl isopropyl ring is there. The benzene. Very simple to remember this. Synthesis, right? Here the synthesis, the synthesis will be right done by methods. One is a classical synthesis. The classical synthesis is nothing but your the regular synthesis, right? The classical synthesis is nothing but the regular synthesis or the traditional conventional method here. Classical nothing but the conventional method and the regular and the traditional method here to synthesize this ibuprofen. And another is a chiral pool synthesis, chirality pool synthesis here. So you can synthesize this particular compound by using the chiral catalyst here. Chiral by also. Right. So here the what is the advantage of this chiral pool synthesis? So here you will right easily operate, right? You will easily the separate your enantiomeric pure compound. Here is this chiral chiral synthesis, right? Synthesis. The estimate synthesis uh, means where you will get the mixture of isomers, right? So you will get the mixture of isomers here. In this mixture of isomers, generally we will get the retention configuration and the inversion configuration. Both products are the multiple products. You can say it is a multiple products are formed here. So in this particular conventional method, right, or the what is it, classical synthesis or a classical method. So you will get the racemic mixture, right? You will get the racemic mixture compound. And from that racemic mixture, you have to separate that by doing the resolution. And it is somewhat tedious method. It is a tedious method, means difficulty, some difficulty will be there, and you will lose some yield product here. So the yield will be less because some compound will be lost by in the workup process here. But in the chiral pool synthesis, right? So you will get the more yield here. You will get the more yield because the wastage of the molecule, right? The wastage of the product is less here because we are using the chiral catalyst here. So that chiral catalyst will be right. So it will be produce only one isomer here. Okay, only one isomer. So it is no further separation is required or the resolution. No further resolution is required here. So we are right. So we are cutting down the right. We are cutting down the work here. We are reducing the work here. So if the steps are reduced, then there is scope for increasing the yield. Yield means the product obtaining in the end of the reaction here, right? So like okay. Now so here it's okay. So this classical synthesis, classical is the material are readily available materials here, and the expand the it is inexpensive method because only the readily available reagents and chemicals are used for this. But in the chiral you need to take the so the expensive metal. It is very expensive metal. This not expensive, but you will get the compound few isomers, and with the increased heat, you sorry, this synthesis begins with the benzene. Okay, the synthesis begins with the benzene here. So first you take the benzene and you do the Friedel-Crafts alkylation by taking the secondary butyl chloride. Okay, there is a secondary butyl chloride. When you take this secondary butyl chloride, sorry, here taking the isopropyl chloride, you will like this acylation reaction, right? So where this isopropyl group is going to attach it in on that benzene ring here, then you will get the isobutyl benzene. Okay, and then further you when you do the ester, right? When you reaction with your aluminum chloride, and generally we call it is a Friedel-Crafts acylation, right? Here is not alkylation, here is acylation. Friedel-Crafts acylation. Friedel-Crafts acylation. This is the alkylation. This is the acylation, right? So it is not alkylation, it is acylation. Okay. So upon Friedel-Crafts acylation reaction, with the from this acetyl chloride, sorry, acetic anhydride. Okay, this is the acetic anhydride, right? So this part is going to attach our adhesives, right? So upon Friedel-Crafts acylation reaction, at para position, okay, at para position, where the acetyl group is going to attach here. Here at to para position, you see the isopropyl group. Here is the acetyl group is there. Then you do the addition with the hydrogen cyanide, HCN addition on your carbonyl group here, right? On your carbonyl. So here H plus Cn minus here. So where this Cn minus is going to attach on this carbonyl group here, then it is going to add it on that particular uh, carbonyl group here. Then we are getting this cyanohydrin, right? Cyanohydrin as a intermediate product here, right? So this cyanohydrin. So upon reduction, right? So upon reduction, where this particular yeah. So upon reduction with hydrogen iodide and in the presence of red phosphorus here, right? So where you will get this particular right. So the alcohol converts into alkyl group here. Alcohol converts into alkyl group here. Right? Then upon doing the hydrolysis, so generally upon hydrolysis, the cyanide group is right. Upon hydrolysis, here the cyanide group is converting into acid group, carboxylic acid. Right? It's going to convert into cyanide group is converting into carboxylic acid group here. Okay, and this particular compound which are formed is it is racemic mixture. Okay, so this is nothing but your ibuprofen only, and this ibuprofen is obtained as a racemic mixture. Okay, yeah, the plus and minus here, racemic mixture, racemate. Right, so in the racemate, right, so we need only the minus isomer, but the plus isomer is not required here. So you have to separate, right? You have to separate these two isomers by doing the resolution technique, right? So by doing the resolution technique here in the presence of what is that syncodine base, syncodine base here, when you do the resolution means separation, right? Where the S isomer and R isomer, both S and R isomer, they both will be separated. But we need only the S isomer. So you take this S isomer and you can discard your R isomer here. Right? So that is your conventional method or the classical method for the synthesis of ibuprofen. And next, the chiral pool synthesis here. Chirality pool synthesis. So chirality pool synthesis, nothing but where we will use the chiral catalyst here. That's all, right? Remaining all are same. Okay. So here in this chiral pool synthesis, the advantage is so only S isomer is formed, right? So it won't use the R isomer here. Only S isomer. Our desired, our required compound will be produced here. Okay. That is the advantage of your chiral pool synthesis here. But in the classical approach, you won't get the exclusive one product here. Exclusive one product. You will get the isomeric products, means two products like racemic mixture. Okay. Then further you have to do the resolution technique and you separate your R isomer or the S isomer, whatever respectively. But here when you how synthesis is here same. Begins with propyl chloride top if this isopropyl group is attached on the benzene here, then it becomes isopropyl. Sorry, iso what is that? Isopropyl. Not so become propyl there. Then upon doing Friedel acceleration reaction, where this further you with HCl, so the carbon group is added by your cyanide group, then it gives you okay, on doing the hydrolysis where the cyanide group is hydrolysis, the cyanide group of acid here is converting into carboxylic acid. Okay, so after that, where here this so in the OH is going to remove as a minus D. This what is it? So, uh, like vinyl, sorry, not only it is the vinyl benzene, right? Isobutyl vinyl benzene is obtained. And further, at this stage, you use by this is by NAP here, by naphthalene. Okay, so yes, by NAP. This is acting as a chiral catalyst. Need yes isomers to okay. Then the asymmetric right, will form in the presence of these particular list here. Right, then the exclusive product of yes, I yeah. So yeah, here is a S oxide. This is a S of ruthenium catalyst here. S of lithium catalyst. Yes, by naphthalene. Is attached with the lithium catalyst here. Okay, so this is acting as a catalyst. Then it gives the exclusive product of your, what is it? Ibuprofen. Yes, ibuprofen. Much of that chiral full synthesis. But next, this is so you have to say thing is starting with okay class be on our okay. Right, so to naphthalene. So when this naphthalene is undergoing reacting reaction, okay, ethyl ether of so naphthyl methyl ether, we call this is the nerolin, right? So we call it is a nerolin here. Naphthyl methyl ether, nerolin, and generally we use this nerolin in the nail polish here. Right? So then this particular methyl naphthyl methyl ether is underwent the pre-idle cropped acylation reaction, right? Then it undergoes the acylation reaction here. Then the acetyl group is going to add this means the second position of the another benzene ring here becomes two, right? So the two acetyl methyl ether here. Then further it is going to reacted by your hydrogen cyanide. The addition reaction is takes place same as your ibuprofen, right? So here the Cn minus is going to attack on, right? Cn minus is going to attack on your carbon group here. Then this will be polarized and it is forming as OH here, and it is cyanide. Cyanide. Okay. Then where this the hydrogen from here, right? So it shifts it towards this one. It remove the so minus H2OH takes place. Then you will get this particular compound here. Then upon doing the hydrolysis, where this cyanide group is into acid, carboxylic acid, right? So we get this. Then by adding means upon doing that hydrogenation reaction, right? Hydrogenation reaction, H2 catalyst. So palladium catalyst, you can use any catalyst, palladium or nickel or the what is that Wilkinson catalyst reaction also. So all the catalyst you can use whatever the catalyst you use. Upon doing the hydrogenation reactions here, where this particular double bond, right? So olefin is converting into alkene here, where the hydrogens are added here, two hydrogens added, and it becomes methyl here. So upon doing the hydrogen catalyst here, where this olefin is converting into alkene here, then here it gives a plus of minus the racemic mixture of naproxen here. So this naproxen further upon doing the resolution with base, right? Resolution with base here, it is going to give you the pure form of your naproxen. Yes, naproxen here. And in the chiral pool synthesis, so same method is used, but at this stage where we are using the asymmetric carboxylation with S by naught, same, right? S by naught is used, then where the S isomer is separated. Okay, and yeah, next is a synthesis of S propranolol. So S propranolol, it is anti-hypertensive drug here, right? It is a beta blocker, right? It is a beta blocker here, beta blocker and anti-hypertensive drug. Generally here, it is marketed as the racemic mixture here because you see, uh, means the conditions, right? In the case one and case two like that. So in that, right? So where the other isomer, right? Here the eutomer, right? Here the S isomer, S propanol is the eutomer here, right? The S, it is a eutomer, more active isomer here, and R, okay. So R isomer is a distomer, right? So distomer. So here the S isomer is active compound, it is inactive compound, and this is not having any side effect here. And the separation of these two isomer is very difficult. In that case, you can use, right? It can marketed or it can use as a racemic mixture or the racemate here because there is no side effects of your the distomer isomer here. That's why, and the when the separation is difficulty, then you can use as a racemic mixture here, right? So like that, this is marketed as a racemic mixture here, racemic mixture. Okay, and the synthesis generally here depending on the right the substituents, right? So we'll give the different uh, means propanol derivatives here, right? So here this is the general formula, right? So this is a general formula of propanol, right? Anti-hypertensive drug, and here is a R group, right? And here is a AR group here, aromatic, right? Aromatic means a RL group and R. So by changing of the RL group, by substitution of the various or the different alkyl group and RL groups, so it gives a different drugs here. And the synthesis is very simple, where it is starting from what is it, epichlorohydrin, right? So where this is the epoxide ring here. This is the oxy, right? Epoxide, oxidane, or the epoxide, right? So here the chloromethyl epoxide, we called it is. So here the epichlorohydrin here, when it is reacting with your, what is that, phenoxide ion, right? AOR, yeah, sorry, ARO minus means phenoxide ion here. So where this, okay, this will be substitute on this, then it is going to attach on this. Then further reacting with the base like primary amine, right? The primary amine here, this primary amine is going to react with this particular epoxide ring, where the epoxide ring opening will be takes place, right? So this primary amine here, the base, right, NH2 minus, it is going to attack on this epoxide ring, okay, and this ring is going to open. The epoxide ring opening will be takes place, and it is going to give this intermediate structure. And upon, means by changing of the R group here and the RL group, so we'll get the different structures and the derivatives here, where if the R equal to isopropyl group and aromatic AR group is naphthalene, then it is propanol R. And R is a isopropyl group, and what is that? AR group. Okay, RL group is what is that? Yeah, benzamide. Okay, so benzamide group here, then it is etenolol. And if R group is isopropyl and the aromatic group is uh, methoxyethyl benzene, right? Methoxyethyl benzene, then it is metoprolol. All are antihypertensive drugs. All are antihypertensive drugs only. And the synthesis is very simple. Like you can right. So treat with the phenoxide ion here. Then you treat with the base, and you will get your compound here. It's a chiral pool synthesis. In the chiral pool synthesis, we have two methods like ARCO process here, right? So where here in this particular in this ARCO process where we are using the DET. DET means diethyl tartarate, right? Diethyl tartarate. It is sharpless epoxide. Sharpless epoxide. So upon this sharpless epoxide, where the epoxide ring is forming, right? The epoxide here. Right? So upon sharpless epoxide, it is going to give this epoxide compound here. Then upon treating with the sulfonyl chloride, right? RL sulfonyl chloride. This RL sulfonyl attach on that particular and alpha naphthyl, right? So this is your and here is a alpha naphthyl here, right? By treating with alpha naphthyl group, where this alpha naphthyl group is going to attach on this particular, right? It is substituting. It is substituting this RL sulfide. It is going to form the unit compound. Using this propyl where this amine is going to open this epoxide ring and it is giving you S-propanol, the enantiomer pure compound, right? Enantiomer pure compound. The process where it involves a sharpless epoxidation, and another is a enzymatic process, right? Enzymatic in vivo reactions, enzymatic process. So here also same method involved, but only thing is use the lipase enzyme, and also right lipase enzyme. Ramipril is there, and one more. Let's see. Guilty agent. Here, so we'll see what is that? Yeah, we'll see the diltiazem. Diltiazem is also important here. Generally, here it is right synthesis of 2s and 3s diltiazem. So diltiazem is it's calcium ion channel blocker here, right? So generally ion channels are right. So here the ion channels like right. So ion channels like this arrangement is there, right? So where this is the ion channel here. It allows some nutrients like calcium, for example, right? Here the calcium, and after influx of the calcium, so it will be closed. It will be closed. So like gated, right? The gated ion channels here. After means influx of calcium, it will be uh, s- closed here, and in the outflex of the calcium, so that will be open. So closing and opening, that makes ion channel here. Okay, right. And this calcium generally it regulates the smooth muscle contraction and smooth muscle expansion here. So calcium ion channels, they will regulate the smooth muscle contraction and expansion, means the blood flow, right? It maintains the BP here generally. Okay, and this is the diltiazem structure. Okay, so here the diltiazem structure. So it is very very important actually, right? So diltiazem structure. So you have to remember the structure and you remember the mechanism. So the synthesis here is this is also simple actually. If you assume it is simple, it is simple. If you think difficulty, it is difficult generally. So here this synthesis of diltiazem, right? Yeah, you see two chiral centers are there, right? There are two chiral centers, right? Yeah, right. So this is the chiral center here, and this is the chiral center. So chiral 3s, right? 2s and this yeah, right. This is chiral center and this is chiral center. Two chiral centers are there. Synthesis. Right. So here you go with this, you right. So you begin with this synthesis of diltiazem by what is that? Yeah, methoxy benzaldehyde. When it is treated with this particular what is it? Yeah, ester, right? Treated with ester here. So in the presence of sodium methoxide base. Okay. So then where it is going to give this particular intermediate compound here. Okay. After that, it is as a epoxide here. Right. It is going to form a epoxide, and then it leads to give the isomers here. You will get the plus and minus 2, right? Racemic mixture. So you can separate this isomer or the racemic mixture by resolution, right? The resolution process by using the right lipase enzyme. So it is enzymatic synthesis here, right? Lipase enzyme, and after that, generally you will get this particular right the trans product here, right? Where the cis product is separate and it is discarded, and we are taking the trans product, and further we are treating with what is just amino, right? So yeah, here is a thioalcohol. Okay, what is that? Yeah, so here is two amino, right? So like here is a thioalcohol here, right? Thiophenol, amino thiophenol. So by treating with the amino thiophenol, so where this thiophenol is going to add, right? So it is attached on this particular intermediate compound here, 2A or 3S compound here, right? Means what is happening here, where this amino group is going to, okay, so this amino group is going to open the epoxide ring here, right? It is going to open this epoxide ring, then the epoxide ring will, then we are getting this intermediate compound. Okay. Then upon treating with the sodium acetate, right? The treating with sodium acetate. So what is happening here? Where the cyclization is taking place, right? The cyclization reaction is taking place. So in the presence of sodium, estate here, right? So here this, what is that? The hydrogen from here and here this particular, what is that? Ester group to form as a amide here, right? So the cyclization is taking place. Then upon reacting with this particular tertiary amine, right? Reacting with the chlorotertiary amine here, where this side chain is going to attach on the nitrogen. Alkylation is taking place where we are getting your final product as a 2s, 3s delta in here. And then the so you can by habits, okay, you select these four drugs compounds. Yes, I do. And not touching and guilty again and yes, propanol. Right, so these four drugs. Okay, uh, right. So here this is your chiral drugs here, right? So only thing is the chiral means when you synthesize a chiral drug compound here, generally we will get the isomeric forms here, because if any chirality is there, right? Any chirality is there. Chirality means chiral compound is there. So there must be a formation of mixture of compound here. You will get the more than one compound. Okay, and in that mix of the isomeric forms, only one isomer is active one, and remaining are not active one. Okay, so that active compound you will choose, and the inactive compound you may discard that one. You can reject that one. And in some cases, that particular inactive compound may reduce the side effects of your active compound, right? That is we call that is a combination therapy. Combination therapy means when the inactive compound or the low active compound or the inactive compound, it that is also compulsory for the pharmacological activity, because generally here the more active compound, it will be shows the biological activity or the pharmacological activity or the therapeutic activity here. And in addition to this therapeutic activity, it may have the side effects also, right? And that side effect will be reduced or the removed by your the low active or the less active or the non-active compound here, right? That is a distomer. That's why you have to take that compound, take that medicine or the drug compound in the racemic form, racemic mixture form here. Okay, so that is called what is it, combination therapy here. So like that, we'll go with this particular chiral drug synthesis and by two methods like classical approach and the chiral pool synthesis here. Okay. And the drug classification generally, what are the drug classification? That is also important. So NSAID drugs. NSAID drugs means non-steroidal anti-inflammatory drugs. NSAID means non-steroidal anti-inflammatory drugs here. So generally here they are having less side effects. NSAIDs are less side effect drugs, and generally the NSAIDs are low active compound actually, right? Slowly active there, right? Slowly they show the what is that, sir? It is a time, it means it take time to show its activity. But the steroidal compounds, they have efficient activity, but they have that much side effects. So the steroidal drugs compound or the drugs are not preferable generally. Okay. So NSAID drugs and beta blockers here. Beta blockers means which blocks the beta receptor, beta histamine receptors here. Okay. So beta histamine receptor is present in the means it is regulates your smooth muscle, right? Smooth muscle contraction and expansion here, which is surrounded by your heart muscles here. Okay. And the next category is the ACE inhibitors. ACE inhibitors, these are antihypertensive drugs here, right? Where they will block the angiotensin converting enzyme and they will reduce the blood pressure, BP. Okay. So these are the classification of your particular uh, chiral drugs here. Okay. Right. So this is your chiral drug. So I am stopping here. So we'll start the only one unit is left here. So in the next week, we'll complete the syllabus. So I'm stopping here now. Okay.